Hello, everyone. It's my great pleasure to welcome you to the Nature-Inspired Solution Graduate Online Open event. My name is Yang Lang. I'm the director of the Nature-Inspired Solution MSc program. Our department is proud to have been the very first chemical engineering department in the UK and have been founded in 1923. So we will be celebrating our centenary this year. The Faculty of Engineering Science at UCL has been recognized as a global leader in engineering education in a recent survey by MIT in the US. And the chemical engineering programs are considered one of the best in the world by many industrial and academic experts. So one of our staff here today will tell you more about the details of the program. So I would like to finish by saying that I would very much like to welcome you to join us at UCL this year in autumn for you to become a student in our Nature-Inspired Solution MSc program. I will now hand over to Dr. Diego López Barreiro, who will lead this session.
Okay, thank you, Yang. I hope everyone can hear me. Hello everyone. My name is Diego, and I'm going to be introducing today the master's program here at the Chemical Engineering Department in UCL that is called the Nature-Inspired Solutions Masters. Together with me, I have here Mark Bernardes as our communications officer. You also heard already Yang, who's the program director, and we have also Eric Hauke, who's one of the students of this year's cohort. So if you have any questions for any of us, feel free to post them in the chat, as Mark said, and after I finish going through the details of the program, we'll have a Q&A session where we will be very happy to answer any questions that you have. So I would like to start talking about this program by first talking about the home of this program, and that's UCL. So we are quite old university. We are almost 200 years old now. We're actually the first university in England that admitted students from any ethnicity, class, religious background, and also the first university that welcomed men and women on equal terms. We're also the first university in England to teach experimental science, modern European languages, and law. And even though we are 200 years old, or almost, we are still providing excellent and very relevant research and teaching to the world. So at UCL, we like to be disruptive. As you can see here, we have always challenged the status quo, and that has led us to become an internationally recognized, diverse, and open university. As a result of this high quality in our teaching and in our research, we are placed among the world's top institutions in many rankings, and I'm citing here a few of them. So you see that UCL is ranked globally as 9th university in the world. We are in the top 10. Several of our faculties are even highly ranked. We have, for instance, the Institute for Education, which is ranked #1 for education. We're also very recently named the University of the Year for 2024, so we are very happy about that. And we are also a top-rated university in the UK for research strength, which is shown here in these pictures that you can see on the right side. We have the REF in the UK, which is a measure of our research excellence. And we have been ranked #1 in London and #2 in the UK. We have also this excellence in research also has been reflected by a number of Nobel Prizes that have been awarded to people working at UCL, the most recent of them being awarded in 2020. So as you can see, we're an excellent university, and as a result of that, we are always able to attract interest from many industries. You can see here some names of some companies that collaborate with UCL, but I also encourage you to take a look at the information that you can find either in the link that is mentioned in this page, or also using the QR code that is included here to learn a little bit more about our industrial collaborations. So where are we? Well, UCL has several campuses across London, but our department, the Department of Chemical Engineering, is based mostly in it's based in two campuses. We have the Central London campus, which we call the Bloomsbury campus, which is very central. It's very close to St. Pancras, the international station in London. It's also very close to the British Museum, so you are at the heart of London. However, UCL is also currently undergoing the biggest expansion since its foundation, and this has led to the creation of the UCL East campus in the east side of London. And I think this is actually one of the most exciting things about the program, because this UCL East campus is an amazing campus. It's very close to central London, so it's easily commutable by train or by metro. So you can get to central London by train with a 7-minute train ride. You can also use the tube, and in 20 minutes you're also in central London and in UCL Bloomsbury. So it's very well connected. But the fact that we are in this space that also has a lot of open space and green space, as you can see in this picture, allows us to try and develop new ways of teaching and of doing research. So this campus, this UCL campus, is a hub for education, for culture, for arts, and for commerce. And it brings together 9 different faculties that are working across disciplines. So this is, again, another example of our disruptive thinking. So we are here in this campus, we are no longer compartmentalizing teaching and research into silos. We are not separating research from chemical engineering from the research in other departments, because we think that the key for the next disruptive technologies will happen at the interface between disciplines. So all our programs, all our labs are coordinated with different faculties and different departments in the university to embed them with this interdisciplinary character. So as a result of that, we are launching, or we have launched 16 new interdisciplinary programs, and also multiple interdisciplinary labs. One of them is the Manufacturing Futures Lab, and that lab is actually the home of this MSc for Nature-Inspired Solutions. So this lab, and I will talk a little bit about it in the next slides, is the place where you would be doing a research project during term 3. I'm actually very excited to work in this campus. It's a marvelous campus. It looks very beautiful. I have here some pictures that I took with my phone several months ago, so you can see how pretty the facilities are, how new everything is. This is a more general perspective of the campus. So it's really an amazing place to live, to study, and to do research. Chemical engineering as a department is part of the Faculty of Engineering Sciences, which encompasses other engineering departments, which are shown here in this slide. Chemical engineering, our own department, is actually ranked top 5 in the UK, and as I mentioned before, is also in the top 20 in the world. One thing that I would like to mention about our department compared to other chemical engineering departments in the UK that are also rated in excellent positions is this rank, is that UCL is actually a larger university than most of the other universities that rank higher in these programs, and it's also in the center of London, which is an amazing place to live and learn, because it is a truly global and multicultural city. So I think that these are benefits that you can only enjoy if you're actually at UCL. As a result of this interesting, or these positive aspects of UCL, our department is very popular among students. As a result of that, we are offering several different programs, either at the UCL East campus or at the UCL Bloomsbury campus, and you can see them here. We teach MSc, MEng, BEng, and also PhD programs. And these programs are all highly demanded and have a lot of students every year. So you can see that our population of undergrad students is over 500. We have over 100 MSc students. Traditionally, we have been offered two MSc programs, which are chemical process engineering and global management of natural resources. But now we have also these programs at UCLA, nature-inspired solutions, advanced propulsion, and digital manufacturing of advanced materials. As a result, we are attracting a lot of students, and if you would join our department, you would be surrounded by people from many different places in the world that come here to London to study in our programs. Some other interesting things about our department are the taster lectures that you can find in YouTube. So if you check our YouTube channel, we will find different taster lectures about different topics that we teach or do research about in our department. And also one thing I would like to mention, something that we feel really proud of, is our Athena Swan Gold Award. This award was awarded to us last year, and it showcases our efforts towards diversity, equality, and inclusion. I mention this because this is an honor that so far only 19 departments in the UK have. So we are really, really proud of this recognition. Now, as Jan mentioned, I said before that our university is almost 200 years old, but also our department is rather old. So we're actually celebrating our 100th anniversary this year. So as a result, we have many different events. I also encourage you to check our centenary video on YouTube and check the different different activities that we're going to be organizing throughout the year, because you only become 100 years old once a year. So we think that this deserves a big celebration. What else? So talking more about the department, we are very active in research. So chemical engineering has traditionally been a very broad discipline, as shown by the multiple fields in which chemical engineering chemical engineers are active. And this reflects in our teaching and in our research. So that means that we not only welcome students from chemical engineering. If you're not a chemical engineering, that's totally fine. We work with physicists, chemists, other engineers. We have doctors as well. Our objective with this and the other MScs that we have is that no matter what your background is, as long as you have a science or engineering background, you will be able to learn and to apply nature-inspired solutions to a topic of your interest. As a result of this broad character of chemical engineering, you can see that the research fields that we cover in our department are also very broad, and we are doing cutting-edge research in all of them. So we are active in all these 6 themes that you can see here, and you can see that one of those themes is nature-inspired chemical engineering. So I guess you can clearly guess that doing world-leading research in this area in our department is one of the reasons why we now have this nature-inspired solutions master at UCL. So it all comes from the excellent research that we have been doing here in our department with regards to nature-inspired chemical engineering. This excellence in research also translates in the existence of 3 research centers that are very, very prestigious. And one of them is the Center for Nature-Inspired Engineering, or CNI. So our MSc, Nature-Inspired Solutions, actually stems from the success and the experience of this Center for Nature-Inspired Engineering. And what we do here at the CNI is that we like to create pioneering or develop pioneering breakthroughs in science and technology that allow us to develop technological solutions to grand challenges such as engineering, materials, sustainable manufacturing, healthcare, the environment. So now I'm going to start talking more specifically about the program. So I have introduced the university, the faculty, the department, and I would like now to take a deep dive into what the program is. And for that, I would like to start with a question for you. So I always use this picture, and I like to ask my students always what they think the most technologically advanced instrument in this picture is. And when I do this, students always start arguing, and some of them say that it's a computer because it has many functions, or it's the the phone because it's like a miniaturized version of a computer. But in my opinion, the most advanced, most technologically advanced thing that you can see in this picture is actually the plant. And the reason for that is that if you think about a plant and you compare it with all our human-made technological devices, a plant is able to self-assemble, it can self-heal, it can self-replicate, it's made from renewable sources, it's able to sense and respond to changes in the environment, and it doesn't use electricity to be powered. So features are features that currently we are not able to replicate in our human-made technologies. So this is telling us that there is something we can learn from nature and from natural systems and natural materials to develop better, more efficient, more sustainable technological solutions for our science and engineering problems. So the problems that we like to address, taking inspiration from nature, are grand challenges. And I briefly mentioned them a couple of slides ago. I talked about things like healthcare, energy, food, water, ecosystems. So all these things have been, all these grand challenges are the topics that interest us and the kind of topics in which you would be developing solutions in this program. So grand challenges, there are several lists that describe them. We have the Sustainable Development Goals from the United Nations, different engineering or science councils throughout the world have also created their own lists of grand challenges. At UCL, we also have our list of grand challenges. But the message, regardless of the list that you look at, is that there are several issues that require immediate attention and disruptive solutions to make the world a more sustainable, more habitable, and a more equitable place for everyone. So the message is that we have several pressing challenges and that those challenges require immediate action. Now, if you think about these challenges like climate change, energy supply, plastic pollution, healthcare, pandemics, you might feel powerless because they are very, very complex problems. But luckily here at UCL, we have one approach to tackle them. And that approach is called the Nature-Inspired Solutions Methodology, which is what you would be studying in this program. So what we do here is basically we learn from the materials, the architectures, or the dynamics that you can find in natural systems, and we use those learnings to design and synthesize innovative and superior solutions to technological challenges. As I mentioned a few slides ago, this approach has been globally pioneered here at UCL, thanks to the Center for Nature-Inspired Engineering, which was founded more than a decade ago. And to give you some examples of how we think about nature and how we can translate that into technological solutions, I would like to give you a few examples. So for instance, if you look about, if you think about lungs or kidneys or trees, they all have the same similar branching architecture, right? However, they have very different functions. Lungs are used to exchange gases between air and blood. Kidneys are more a sort of like purification system in our body. And trees have also a supportive role that helps deliver nutrients throughout the structure of the tree. So this shows us that, or the fact that these similar structures with very different functionalities exist in nature and have evolved in nature throughout millennia and millennia is telling us that there must be some advantage of these systems. So there must be something that we can learn from the design or the working principles of these systems so that we can develop technological solutions that we can use, for instance, to develop better gasification reactors or better membranes for water filtration or better architected materials for catalysis or biomedicine. Another example is that if you think about cancer development or epidemic spreading or the growth of population, they are all extremely different type of events, but they can be described using similar principles of dynamic models. So these kind of common aspects between seemingly different systems in nature are the kind of things that you would be looking at in our program to try to extract their functioning, their functional principles, how they work, how we can explain their benefits of those structures, of those dynamics, so that we can implement them, use those universal principles that we find in those natural systems and apply them to a topic of your interest. And that can be renewable energy, materials, biomedicine, architecture. What I mean with this is that our program is actually built to give you flexibility in the application you pursue, because what we like is to understand the solutions that nature has developed, and then we like to apply those solutions to different types of problems. To showcase the diversity of problems that we address with this nature-inspired solutions methodology, I'm showing here in this slide several technologies that have been developed here at UCL. For instance, we looked at the structure of lungs to develop better fuel cells. We looked at the structure of cell membranes in our body to develop better filtration membranes that prevent fouling. We also looked at the complexity of natural systems to develop better anti-cancer treatments. Or we have taken inspiration from the structure of trees to develop more efficient fluidized bed reactors, or the structure from leaves to develop better structured catalysts. So you can see here the breadth of topics that we can address by looking into nature and taking inspiration from natural systems. So I hope that by now it's clear that this program, even though it is in the chemical engineering department, is not just for chemical engineers. We have, in fact, students from many different disciplines with us. We have physicists, we have chemists, we have material scientists, biomedical engineers, architects, or any allied field from these disciplines. So we will be happy to welcome you as long as you have a science or technology background and that you're interested in applying nature-inspired solutions to the field in which you have studied. To access the program, there is a minimum requirement of an upper second class from a UK university or an equivalent qualification from an overseas university. Although, if you have a special case, I encourage you to contact the program director and discuss it with him, because there might be some options for you to join the program if you don't meet these requirements. Also, candidates coming from an industrial background are also encouraged to apply, because we have also collaborated a lot with industry, and we see that this approach is very appreciated in industry. So we are also very happy to welcome students that have a previous industrial experience. So you don't need to be fresh from your undergrad to apply from this program. We're also happy to welcome people that have been working for a number of years in industry now. Now, what is the structure of this program? Well, it is a one-year postgraduate program, so it lasts for 1 year. And it's also a research-related teaching. And this is actually for me, one of the biggest selling points from UCL. And that is that all the things we teach here, all the things you learn in our programs are related back to cutting-edge research that we do at UCL. So this connection between research and teaching, I think it's something unique of UCL, and it's one of the most interesting things that we offer. So if you join us, you will be able to, or you will be equipped with the skills that you need to drive by inspiration to tackle grand challenges in, as I said, in many different areas. And it will give you, or this program will give you a unique competitive edge that is increasingly demanded in research and development, in entrepreneurship, and also in industry. If you want to learn more about our program, I encourage you to check these two videos. We have one video available specifically about our program, so you can check it and learn more details about our program and about the teaching staff involved in it. And I would also like to encourage you to take a look at the second video, which showcases specific examples of technologies that we have developed here at UCL and that have been inspired by nature. So should you join this program, at the end of it, after 1 year with us, you should be able to implement fundamental principles from nature to solve engineering or scientific problems. You should be able also to recognize in which situations this nature-inspired solutions methodology will help you come up with a better performing solution. And you will get to that point by working in interdisciplinary things, solving engineering problems, working on design problems. You will have to present your work, you will have to work in teams, so you will have to develop leadership skills in solving practical engineering problems. Thanks to the multidisciplinary character of this program, you will also be exposed to people from different backgrounds, which is something that is very useful then when you try to apply for jobs, because you will have to talk to classmates that have studied maybe something different from what you studied. So you have to find the ways to communicate with each other, develop solutions together, and present them and defend them in your classes. So these are all very exciting things, but another very exciting thing about this program, which I already mentioned at the beginning, is that it is in London. And by joining this program, you would get to live in one of the most vibrant cities in the world, which is an amazing experience, in my opinion. So why London? Well, London is very multicultural, very vibrant. There is always something going on in London, so you will not be bored if you come to London. And it's a fantastic place to come, learn, live, and grow. You will never be short of things to do. But a good thing also of London is not only what you have in London, is that it's also very well connected to many other places. So from London, you will have fast access to rail and air links from UCL to everywhere in Europe. So the whole of the UK and many other European countries are very easily accessed from London via train or via plane. Now, in terms of the program structure, it's a program with 180 credits. It lasts for 1 year, and it has 3 terms. In the first 2 terms, you will have a combination of lectures and lab practices, and you will have a few compulsory modules, which are shown in yellow, and a few and in blue, and a few optional modules, which are shown in green. And those optional modules can be either specific from the program, and those are shown here in red, or also we have some more general UCList modules related to things like life cycle assessment, sustainability, entrepreneurship. So you're encouraged to join any of those. And on term 3, which is from May onwards, you will be doing a research project. And that research project is what you will be doing at the Manufacturing Futures Lab. So this will be an individual project. So you will be working on your own with the supervision of a member of the academic staff of the department. So me, Yang, or other people from the department would be supervising you. We will find a project for you, and you will, throughout this research project, you will develop and enhance your abilities to guide the project, to show that you're able to supervise it and deliver results. You can choose the topic of your project from the research areas in which staff members from our department are currently active. And as I said, the project happens at MFL, at the Manufacturing Futures Lab. So what is MFL, or where is MFL? Well, MFL is here. So we are in this building from the campus. It's called the Marshgate building. We are on the 7th and 8th floors from this building. And the Manufacturing Futures Lab is a multidisciplinary research hub. It underpins end-to-end production of new products. And our objective is to focus on how these products, these materials, these chemicals will be produced in the future. How can we make them smarter, faster, more flexible, more sustainable than we currently do. So this is our focus. We are focused on how we will make things in the future. To do so, Manufacturing Futures Lab is bringing together 4 different departments. So if you join the program, you will be learning a program from the chemical engineering department, but during your research project, you will be in a lab where you will be interacting with people from the chemical engineering, the biochemical engineering, the mechanical engineering, and the chemistry department. So this is a lab space. MFL is a lab space that has 1,500 square meters without walls. So the idea here is to promote interdisciplinarity, collaboration across disciplines, so that we don't have the chemical engineers working on their own and the mechanical engineers working on their own and the biotechnologists working on their own. We want all of them to work together, to talk to each other, to have an interactive space where research, collaboration, interdisciplinary ideas can happen. And this is Manufacturing Futures Lab. To do this research project, you will get the chance to work with world-class equipment. So we have many different types of instruments in the lab. I'm showing here just a few of them. but it's really an enormous space. You have to think that we are talking about 1,500 square meters of research space. So we have all sorts of analytical techniques. So depending on whether you want to work on a biomedical problem, a sustainability problem, a renewable energy problem, a process engineering problem, a material science problem, we have equipment that will help you obtain world-class data, world-class results, and do world-class science. Here I have some pictures. I also took them with my phone several months ago. They are pictures from the labs before they were empty. As you can imagine now, they don't look like that anymore. They are populated by a lot of students and instruments and chemicals. So they look a little bit different now, but this is the space where you would be working, where you would be doing your research project during term 3. These are also the teaching spaces. So these are when you have a lab session in your modules on term 1 and term 2. This is the lab where you will also be working. So you will also have exposure to the lab during the first terms of the program. And here is the last batch of pictures that I wanted to show you. So you see that the space is enormous. We have many fume hoods. We have double-deck lab spaces. We have really amazing facilities for you to carry out your research projects. In terms of how you will be assessed, well, the teaching strategy is that this is a face-to-face program, so it is not online, it is on campus, so you have to be physically present in London to attend this program, and attend lectures that will be tutorials, workshops, theoretical lectures, laboratory sessions, and you might also have some online materials, some pre-recorded videos or reading material that will supplement those lectures, but it's a face-to-face program. And the way you will be assessed will be comprised of a mixture of different types of assessment methods. So depending on the module, you will have coursework, reports, team projects, examinations, quizzes. So depending on the module, you've seen that we will have different modules in the program, and depending on which ones you choose, you will have different types of assessments. Now, to deliver the content, if this is a multidisciplinary program, then we need a multidisciplinary team, and this is what we have assembled here. So the teaching is mostly delivered by these 5 people that you see here. So we have Yang Lang, who's also in this webinar today, who's the director of the program. We also have Marc-Olivier Coppens, who's the founder of the Center for Nature-Inspired Engineering. And then you also have Amita, Solomon, and myself. And we all come from very different backgrounds. So we are, the program is perfectly designed, or the team is perfectly designed to fit with the multidisciplinary character of the MSc. So we have people with experience in membrane technology, in fuel cells, in solar cells, in process engineering. I myself have experience with biopolymers and biomedical materials. So you can see we cover a wide range of research topics. And this is precisely the philosophy that we want to have in our program. We want to have this multidisciplinary character from the beginning, from starting with the teaching team. Okay. Then one last thing that I would like to mention are careers. So if you apply to this program, you will acquire a unique competitive edge to develop sustainable technological solutions. And this is a profile that is increasingly demanded in many sectors. So as you can imagine, there is more and more pressure to increase our sustainability efforts. So people that are students or recent graduates that have experience with developing sustainable solutions, bio-based solutions, bio-inspired solutions are highly demanded. So in that sense, because of the multidisciplinarity of our program, the type of activities that you can work on is also very large. So you can work on many different fields. I'm showing here a few of them. So you can work on biomedical industries, on energy industries, on scalable manufacturing and process intensification, food, agriculture, water treatment. So as you can see, there are many different fields, and actually this information is gathered from the people that have been working with the CNIE throughout this past decade. And we have alumni working in all these fields after having worked with nature-inspired solutions. And then in terms of destinations, that's also a very broad. There is also a very broad range. So you can continue with a professional career in industry, in entrepreneurship. You can also go into policymaking. And of course, you're also welcome to continue with an academic or a research-focused career through a PhD, for example. But in terms of careers, when the moment comes where you start wondering, what am I going to do after the program? I definitely encourage you to check with the UCL careers team. They are an amazing team that have dedicated workshops, lectures that will help you prepare your application materials, your cover letters, your curriculum vitae. So it's really a very useful service. I don't know anyone that went to this service and was disappointed. It's really helpful. They will make their best to help you prepare your application materials to ensure that after your program at UCL, you are in an excellent position to move on to your next step. In terms of how to apply to this program, we have a few scholarships and bursaries available. I'm mentioning here some of them, but I would also like to encourage you to check the information contained in the 2 web pages that I'm mentioning here, and also in the QR code that is included in this slide. And also, please be aware that some scholarships are actually country specific. So depending on where you will be applying from, you might have access to some funding opportunities that will help you financially throughout your MSc program. And I think that's all from my side. That's all I wanted to tell you today. I would like to encourage you to stay in touch with us. Find more information about our MSc program in our prospectus webpage, which is shown here. We also have questions about immigration and visas for the UK. We also have this webpage that will help you with that. And then if you have any specific questions, I definitely encourage you to contact our department, and we have a general postgraduate address for that, which is shown here. But also, please feel free to send an email to Yang Lan, the program director. He will be more than happy to answer your questions and help you with your application. You can also follow our department in our social media accounts, which are listed here. And also our Faculty of Engineering has its own social media account. So please follow all these channels. You will learn about the programs that we teach, the research that we do. And yeah, it will be a very nice and easy way for you to stay in touch with us and see what we are doing. That's all I wanted to mention today. Before you go, please take a couple of minutes to fill in this short survey about your experience today. We want to learn about how useful this was for you. Where did you connect with us from? And yeah, learn a little bit about you and your interests in the program. So please fill in this short survey. And yeah, now the floor is yours. So if you have any question, as I said, we have here the program director. We have Eric out here, who's a student in the program. We have also Mark Bernardes from the communications side. So if you have any questions to any of us, we will be more than happy to try to answer them. So that's all from my side. Thank you very much. Trying to see if there are any questions. If not, I'm thinking if Eric would be happy to say a few words about his experience as a student in this program. Would that be okay for you?
Yeah, absolutely.
Yeah.
So my name's Eric, and I'm a current graduate student here as part of the Nature Inspired Solutions program. Before coming to UCL, I studied behavioral neuroscience for my undergraduate degree in the United States. And after that, I worked in the biotechnology industry for a few years for a couple of various startups. So far, I've really enjoyed the Nature Inspired Solutions program. I've really enjoyed the interdisciplinary nature and being able to learn about a multitude of different topics at the same time, and also with different approaches to some of the same topics as well. I think that for me, it's really interesting, not only learning from nature, the adaptations that have evolved over time, but also how many different ways, different lecturers and different researchers can come up with solutions to similar problems by taking unique approaches that are specialized to their experiences, which I think is, and the same is true for some of our group projects as well. Working with other students who are from different backgrounds, it's really interesting to see some of the different strategies that we each tend to gravitate towards and come up with. Right now, we're finishing up we're halfway through the second term of classes. And I personally am really looking forward to working with Diego on a research project this summer, where I'll be working on biomineralized protein materials. And so I'll be getting to build off of some of my experience in biology and some of my lab skills there, but also learning lots of new skills, both in synthetic biology and materials characterization. And I've definitely I've loved living in London so far. I'd never been to the UK before, and it's certainly a big city at first, but it's been a really great time. The campus here is beautiful. It's awesome to have your own little green space in the city, and really enjoyed it a lot so far. And I'd be happy to answer any questions if they come up at a later date as well. Don't hesitate to reach out. Thanks.
Sorry, I was muted. Thank you very much, Eric. That was really, really nice. Thank you. Yeah, so I don't know if we have any questions in the chat from any of the attendees. Okay, well, then if there are no questions from the attendings, then I think we can finish here for today. So thanks everyone for joining, and we are definitely looking forward to welcoming you in September here at UCL. Thank you very much for joining today, and have a good rest of the day.
Thank you, Diego and Eric. Thank you all.
Bye-bye. Bye-bye.